Welcome to class today. Today we are going to be talking about water, but most importantly, we're going to be talking about the properties and the states of water. So what do you know about water? When someone asks, what do you think of water? What are the first things that come to your mind? I want you guys to answer this. It's just an open-ended question, just to kind of start to get you guys thinking about water. So when I answered this question for myself, I came up with three things. I thought of first that I can drink it. I know that I can have a glass of water. I can drink water. I also thought of playing in it. My family has a pool, and so in the summers we always would play in water. I also go fishing, so that's another playful type thing that I can do with water. And then I also thought, well, it can be cold or warm because I love to drink a cold glass of water, but I also love to have like hot chocolate, right? And that's a little bit warmer. So those were three things that I first thought of with water. Well, today we're going to add to that list of some things that you know about water. First of that is that water has states. It has three of them to be exact. So when you think of water, you'll be able to now know the three states of water. The three states of water include solid, liquid, and gas. In the solid state, that is something we can think of as an ice cube, right? It's a solid form of water. And then a liquid form of water, we can think of a glass of water, the water that we drink. And then for gas, we can think of the steam that rises from a pot of boiling water, the gas that's rising. Those are three states of water and examples of each of those states. So when we think about the states of water, we really have to focus in on the molecules of water. So in the gas state, the water molecules are going like crazy. They're bouncing off the walls. They don't have an exact form. They don't go in an exact way. They're just crazy moving and they're pretty fast. And then in the liquid state, the molecules are not as fast moving, but they're not moving like they are in a solid state. In a liquid state, the molecules are closer together than in a gas state, but they still are moving and have a free-flowing pattern. And then in the solid state, the molecules are not moving at all. They are solid and they are still. And they also have an exact form. If you can tell that those molecules follow in an exact pattern and they don't move. So I want you guys to look at this picture and tell me, what state is this? This state is a solid state. There's reasons why we know that it's a solid state. First off, we can tell that they're in an exact pattern, that these are not moving at all, that they stay put like a solid molecules do. What state is this? This is a gas state. So we can tell this first off by the molecules are spread apart, right? They're not close together like they're in a solid state. You can tell that they're moving more. They are covering more area and things like that because the molecules are spread apart. And finally, what state is this? This is a liquid state. So we can tell this because they are not exact, like the molecules aren't as exact as they're in a solid state, but they're still closer together than what they would be in a gas state. They're still flowing and they're not going crazy. So in order for water to change states, certain things have to happen to the molecules because we know that we have those three states, a solid, liquid, and a gas, but they can actually change states, and this all depends on things that happen to the molecules. So, in order for water in the solid state to change to a liquid state, it must be heated, and this causes the molecules to speed up. So if we wanted to go from an ice cube to our glass of drinking water, we would first have to add heat. And by adding heat, these molecules are going to start to break apart. They're not going to be solid anymore in that exact space. They're going to spread apart a little bit more and start moving and become like a liquid and have that movement as those molecules do. And if we wanted to flip this, we could change water in the liquid state to a solid state. And in order to do this, we have to cool it, and this causes the molecules to slow down. So if we wanted to go from our glass of drinking water to our ice cube, we would have to cool it. And a way we can cool it is by placing them in the freezer. So when we place it in the freezer, the molecules in that liquid state are going to come back together. They're going to stop moving. They're going to slow down and they're going to form into a solid. And solid molecules don't move and they have that exact formation. So What is the answer to this question? Liquid water becomes solid ice when blank. When it's cooled, just like we were talking about. So when we place that liquid water, our drinking water, in the freezer, it forms an ice cube, and this all happens because it's cooling. It's allowing those molecules to come back together and form a solid formation. And then now answer this question. Solid ice becomes liquid water when blank. When it's heated. So when we have our ice cube and we want to turn it into liquid water, we add heat, we add warmth. And by adding that warmth, the molecules then start to spread apart and start to move a little bit, and then they are able to form into a liquid. Finally, we're going to talk about water vapor. So gas is known as water vapor. It's created when liquid water is heated. So, in order for water in the liquid state to change to a gas state, which is also gases are water vapor, it has to be heated, and this causes molecules to speed up. So, if we wanted to go from our liquid drinking water to our gas, that water vapor that rises, we would have to add heat. So, in a liquid state, we know the molecules are moving, but they're not going crazy fast. And so by adding that heat, we allow those molecules to start speeding up even more, and they are able to form into gas, which is known as water vapor. So I want you to answer this question. Liquid water becomes water blank when heated. Becomes water vapor. So we know that water vapor is gas. So when we heat up that liquid water, what are we doing? We're creating water vapor. We're creating molecules that are going super fast, and that is what water vapor is. We're now going to transition into properties of water. So we have 3 different properties of water that we're going to talk about today, as well as another one. But these 3 all kind of go hand in hand. So first we're going to talk about cohesion. I want you guys to look at this picture. These are 2 water molecules. And I want you to look at them closely and decide for yourself what is cohesion based on this picture. So with this, what this picture is depicting is that when water molecules want to stick together, that's what cohesion is. It's when those 2 molecules are sticking together. They're holding hands in that kind of picture. So we can think of that with our hands as well, right? So we can think, okay, my hands are both the same thing and they want to come and stick together. That's exactly what cohesion is. It's 2 water molecules that are attracted to each other and want to stick together. What is surface tension? So when you look at this picture, you can see a droplet, and what's happening on that? What possibly could be surface tension based on this picture? So surface tension is when water molecules form a tight film on top of the water. So in this picture, we can see that water droplet coming down, right? And it's trying to break the tight film, break the surface tension. So what we can do to think about surface tension is when we interlock our fingers. That's exactly what water molecules do. They interlock and they form a tight film. It creates surface tension on top of water. It creates something that's hard to break, just like it's hard to break when we have our fingers interlocked. That's exactly what water molecules do on top of water. And what is adhesion? So adhesion, look at that picture and see, okay, there's a water molecule in a leaf. What possibly could be happening between those 2? So adhesion is when water molecules want to stick to other things besides water. So in this picture, we have a water molecule sticking to a leaf. They're kind of holding hands, just like the other 2 water molecules were in cohesion. But this time, it's 2 different things. It's a water molecule and a leaf. So adhesion is when 2 things want to adhere to each other. They want to stick to each other, but they're not the same thing. So when like the rain falls, right, we see raindrops coming on leaves. They're adhering to the leaves. They're sticking to the leaves, and they're not the same thing at all. So adhesion is known to stick to blank. Adhesion is known to stick to other things, just like that last slide was talking about, right? We have our leaf and our water droplet, and they adhere to each other. They stick to each other, but they're both completely different things. Blank is when water molecules stick together. That is known as cohesion. So cohesion, right? We have 2 water molecules that want to stick together, just like our hands. Our hands, they want to stick together, and they're the same thing. And surface tension creates a tight blank on top of water. Surface tension creates a tight film on top of water. So it's that interlocking of molecules, the interlocking of our fingers, right? Creates a tight film that's going to be on top of water that's really hard to break. And that is what surface tension is that film that's really hard to break on top of water. The final property we're going to talk about today is repel. So water sometimes does not become part of the object. Water will repel. So we all have seen jackets that will repel water, right? The water droplets will drip down and they won't mix at all, and then it'll just repel off. Water can do this as well. When you think of repelling with water, you can think of water and oil. Water and oil don't mix because water will repel the oil and it won't allow them to mix at all. It repels it rather. So for water to repel, it does not become blank of the object. That is known as part. So the water and oil can't mix because oil can't become part of the water. It can't become part of it at all. It repels it off. So today we learned a lot about the states of water. We learned about a solid, liquid, and a gas. We have our ice cube, we have our glass of drinking water, and then we have our gas, our water vapor. And within these states of water, we learned a lot about molecules. And knowing that as a gas, the molecules are fast flowing, free moving, and are all over the place. And as a liquid, we learned that the molecules are closer together than a gas, but they're still moving. They have some movement to them. And then we know that in a solid state, the molecules are closer together and they are not moving at all. And we learned also that by these molecules, we can then change states. We can go from a liquid to a solid to a liquid, and a liquid to a gas. And by changing these states, we change the molecules, we change the movement. We can increase the movement, we can slow down the movement, and that is what is going to change those states is a lot depending on the molecules. And we also learned today about the properties of water. We learned about cohesion and knowing that it's when two water molecules stick together, they want to stay together and they're the same thing. And we learned about surface tension and that tight film that's on top of the water. The interlocking of our fingers is just like the interlocking of water molecules, and it creates something tight that's hard to be broken. And then we learned about adhesion. Adhesion meaning that it's a water molecule and something other than itself that stick together. And so we can think of a leaf. We can think of the water droplet on the leaf, that they adhere to each other, they stick to each other, but they are not the same thing. And we also learned about repelling. We learned that water can repel things. It doesn't have to allow it to stick to each other and things like that. It can repel it off. Just like water and oil won't mix is because water repels the oil. It won't allow it to mix. So what do you know about water? So when someone asks you that question, you can think of, well, I do drink it. I do play in it sometimes. I do like to go swimming, or maybe I do like to go fishing. You can think, oh, hot and cold. I can drink water that's cold. I can drink water that's hot, like in hot chocolate. But now you know some other things about water. You know that water has 3 states. It can be a solid, liquid, or a gas. You know that it can change states, and that can all depend on the molecules of water. You know that in a gas, the molecules are moving fast. You know that in a liquid, the molecules are moving a little bit, but not as fast as they are in a gas state. And in a solid state, the molecules aren't moving at all. And in order to change the states, we change the molecules. The molecules can speed up or slow down, and it will change the state of that water. And you also learned about certain properties. You know now that water can be cohesive. It can stick to each other, and they can come together and stick and form that bond. You also know about surface tension, and you know that there's a tight formation on top of water, and that's why it's sometimes hard to break surface tension. You can see as that droplet did in that picture, it's trying to break that surface tension, break that tight bond that's formed between those molecules. And you also learned about adhesion. You learned that water can stick to other things besides itself. It doesn't always just stick to each other like it does in cohesion, that it can stick to other things besides itself, like water and a leaf. And you also learned about repelling. You know that water can repel certain things. It can not mix with certain things. It can push them away. It can allow them not to become part of the object. So when people ask you, what do you know about water? You now have like more than 10 things that you can tell them about water, and you'll be very knowledgeable.